Welcome learners. Today's topic of discussion is classification of sedimentary rocks. So, the outline of my talk is I will discuss the classification of sedimentary rocks based on mineralogical composition, based on chemical composition, based on texture, then based on size and shapes of grain and mode of origin, and based on depositional basin, and at the last I will summarize my talk. So, learners, by now we all know that sedimentary rocks they are made up of accumulation of particles of older rocks either as clast or as mineral grains. They are chemically or biogenically precipitated. And some of the examples of sediments are sand, gravel, mud, and also pieces of shells. So, now let us discuss about the classification of sedimentary rocks. So, based on mineralogical composition, sedimentary rocks they can include any mineral because of their detrital nature. So, mineral composition depends on the source of the material, the intensity of mechanical and chemical weathering, and the distance they traveled. So, the minerals of sedimentary rocks they fall into two categories. The first category is insoluble residues of rock decomposition. The next is the detrital minerals or particles, they are derived from the pre-existing rocks. So, the insoluble residues they include the clay minerals, for example, the kaolinite. Those they are produced by chemical weathering. Then micaceous minerals, this includes the mica, that is muscovite and biotite, and chlorite, and the aluminum hydroxides like bauxite and gibbsite, and ferric oxide and hydroxide. So, the carbonate minerals they are either precipitated directly or by organisms. This make up most of the chemical and biochemical sedimentary rocks, but subordinately carbonates also occur in mud rocks and sandstones. So, this is the table of mineral composition of mud rocks and sandstone. Here you can see the mineral composition of clay minerals present in mud rock and sandstones, like 60% of mud rock clay minerals are there in mud rock and 5% of clay minerals are there in sandstone. Likewise, the percentage you can see of the quartz, the feldspar, the carbonate minerals, and also the organic matter. So, you see learners, the pre-existing rocks they are the source of the detrital minerals like quartz, the K-feldspars like orthoclase and microcline, the plagioclase feldspars, and there are also some accessory minerals like zircon, rutile, tourmaline, hematite, and magnetite. And we all know that quartz is stable in conditions found at the earth's surface, because quartz is also a byproduct of the chemical weathering. So, here you can see in this table that most abundant mineral in sandstone is quartz, and quartz is the second most abundant mineral in the mud rocks. So, the most dominant minerals in igneous and metamorphic rocks is feldspar. So, feldspar is the third common mineral in these rocks. So, now let us discuss about the classification based on the origin. So, we can classify minerals found in sedimentary rocks based on their origin into two classes, that is the allogenic minerals and orthogenic minerals. Allogenic minerals, these minerals are formed elsewhere and they are transported into the area of deposition. And for orthogenic minerals, these minerals are formed at the site of deposition either by direct chemical precipitation or by later diagenetic processes. So, now you see the classification of sedimentary rocks based on mineralogical composition. Here most commonly occurring minerals in the sedimentary rocks are quartz, then feldspars, clay minerals, calcite and dolomite. So, sedimentary rocks classified on the basis of frequently occurring minerals. They are summarized in this table, in this table you can see where the predominant mineral is quartz with other minerals like feldspars, cerussite and minerals forming matrix. The name of the rock is sandstone. Likewise, when we see quartz and prominent minerals is quartz and feldspar with some other minerals that you can see in this table like feldspars and minerals that forming the matrix. The name of the rock is feldspatic sandstone or arkose. So, now let us see the classification based on the chemical composition. You see, identification of minerals becomes difficult when the grain size becomes too fine. So, the chemical analysis becomes necessary when the grain size is too fine. So, on the basis of chemical composition, these rocks are divided into siliceous deposit, then carbonate deposit, ferruginous deposit and phosphatic deposits. Here you can see siliceous deposits. They are also further we can divide them into highly siliceous groups, moderately siliceous groups and highly calcareous groups. So, in this table you can see the oxide percentage that varies with respect to sandstone, shale and limestone. So, the siliceous deposits, these are you see the silica is the chief constituent and the chemical composition of sandstone here in this table you can see is 78%, whereas in limestone it is 5% and in shales it is 58%. Carbonate deposits, these are precipitate from carbonate rich waters under different conditions. And for ferruginous deposits, they are mostly the iron deposit, iron carbonate deposits and the most common forms are you see banded iron formations and iron stones. And for phosphatic deposits, they are composed of phosphate minerals and phosphate rock they contain a group of calcium phosphate minerals, for example apatite, and there is also a special term known as guano which is used for you see excreta of certain sea birds or bats and these are the phosphatic deposits. So, here you can see the photograph of a hand specimen of banded iron deposit and also these are the photographs of phosphatic rocks which noodles from this area is from Jamarkota. These are the field photographs. So, now let us discuss the classification of sedimentary rocks that is based on textures. So, two major textures are used in the classification of sedimentary rocks. We all know about the clastic and non-clastic. So, based on textures we can divide into clastic and non-clastic. So, for clastic you see the sedimentary rocks that shows clastic texture consist of discrete fragments and the particles that may be cemented and they can be compacted together and they often result due to the accumulation of materials that originates and is transported as solid particles that is derived from pre-existing rocks, both mechanically or they can be chemically weathered. For examples, you see gravels, then sand and clay. These are the clastic sedimentary rocks. For non-clastic sedimentary rocks, they have non-clastic or crystalline textures, in which the minerals they form a pattern of interlocking crystals. So, non-clastic textures they are found mostly in rocks that have precipitated chemically from water. They are called chemical sedimentary rocks, for example limestone, dolomite and chert. There are also other non-clastic sedimentary rocks that include those formed by organisms. They are called biochemical rocks. For example, you see coquina, and those they are formed from organic materials. We can take example of coal. So, based on size and shape of grains, we can classify the clastic rocks, like the classes are rudiceous, then arenaceous and argillaceous. Here these classes depends upon the constituent particles, and you see this is rudiceous. Here you can see the field photographs of conglomerate and brexia. As rudiceous, they are characterized by the presence of extremely large size constituents in them, and rocks or minerals they are cemented together in a matrix that give rise to conglomerate and brexia. Here the field photographs you can differentiate that conglomerates they are rounded and sub-rounded clast, and the brexia with the angular clast. And for arenaceous, you see they consist of grains that vary between sizes of 2 and 1/16 millimeter, and they are called the arenites. And as these grains vary between sizes of 2 and 1/16 millimeter, they are called sands. Thus, these rocks they are commonly known as sandstones. Here you can see the field photographs of sandstone, where this photograph is the grain size variation in sandstone. You can see medium to very coarse grained sandstones, and B, this is thickly bedded reddish to buff colored ferruginous sandstones. These two are the field photographs. Now you see, let us discuss the classification of sandstones. And there are many classification schemes proposed for sandstones, but Dodds classification is commonly used. So, in Dodds classification, a triangular diagram is plotted between quartz, feldspar and the rock or the lithic fragments, and here this is the triangular plot where you can see the classification of sandstone. And the Q is that denotes the quartz and also the metaquartzites. F denotes the feldspars, and the RF is rock fragments, and here this is the small triangle. This shows the subdivision of lithic arenites. Here you see this classification, Dodds classification. Here the demarcation between the quartz arenite and the quartz wake, this is placed at 12.5. Here you can see this is 12.5, and the boundary between the sandstone and mudstone that has put at 30%. This is where it has put it 30%. And the quartz and the metaquartzites fragments have been grouped together, and the third grains that also have been included in the rock fragments. So, this Dodds classification, this is often visualized using a ternary diagram, as I already told, where there are 3 axes that represent the proportion of quartz, feldspars and rock or lithic fragments. So, this classification helps to assess the compositional and the textural maturity of the sandstones, which indicates the degree of weathering and the transportation of the sediments. So, learners, we were discussing about the rhodaceous and arenaceous classes. Now, next let us discuss about the argillaceous. Here you see argillaceous, they are the rocks that is composed of grain size that is below or very fine than the 1/16 millimeter. They are also called mud rocks. So, those having grains between 1/16 and 1/256 millimeter, they are termed as siltstones. In this classification of argillaceous group, you can see the relations between the unconsolidated, consolidated and the last the metamorphosed rocks that forms. So, now learners, let us discuss about the classification of sandstone based on mode of origin. They are divided into residual sediments, mechanical sediments, chemical sedimentary rocks and organic sedimentary rocks. And for residual sediments, you can see the examples are laterite, bauxites. For chemical sediments, they are sandstone, shale, siltstone. And chemical sedimentary rocks, they are for example limestone, chert, dolomite, ironstone, dripstones like stalactites and stalagmites. And for organic sedimentary rocks, we can take example of coals, stromatolites. So, the accumulation and consolidation of elements left over from the weathering and transportation processes results in residual sediments. For examples, I have already told that they are bauxite and laterite. So, this is the field photograph where you can see that are mechanically transported detrital sediments by running water. So, the rocks and mineral fragments that are formed through mechanical weathering, for example, siltstone, sandstone, shales, they are referred to as mechanical sediments. So, as you are aware that rivers and the ocean, wind and rainwater, they all carry the eroded rock fragments, and these rocks and minerals particles, these make up this debris which we known as detritus. So, as I have told you that in this field photograph, you can see the mechanically transported detrital sediments by running water. This is another field photograph where you can see chemically precipitated limestone. So, chemical sedimentary rocks, they are formed from soluble substances which are removed in solution, and they are deposited to form chemical sedimentary rocks like limestone, dolomite, ironstone, and these chemical sediments can be created by inorganic processes like evaporation, precipitation, and also with some chemical activity. When substances they dissolve in water, this chemically precipitate out of the water, this kind of sedimentary deposition takes place. As you can see in this photograph, they are the chemically precipitated limestone, and this photograph is from cave in Meghalaya, where you can see the stalactites and stalagmites, and this is an example of the dripstones. And these stalactites and stalagmites, they beautify numerous caves. Organic sedimentary rocks, for example, coal. Coal, we all know this is a black combustible rock consisting of organic carbon that originated from the remains of plants accumulated on the floor of swamps. So, this you can see in this photograph, these are the coal beds, and in this photograph where you can see the circular areas, these are stromatolites. They are example of organo-sedimentary in origin, and these stromatolites, they form in shallow waters when these microorganisms, primarily the cyanobacteria, they trap and they bind the sediments, or they stimulate the precipitation of minerals. So, next we see the classification based on depositional basin. Sedimentary rocks can be classified on the basis of placement of sediments in relation to depositional basin, where these sediments they accumulate. They may be extrabasinal, or they are known as allochthonous sediments, or they may be intrabasinal, they are known as autochthonous sediments. So, the classification, or here you can see the table based on the extrabasinal rock types and structure. When the rock types they are rhyolite, ereinite and luteite. You can see the geometry here in this table and the deformation they form. Like for ereinite, the geometry is dunes, burrs and ribbons, and the surface marks can be lode cast and tool marks. Then the deformation is sun sedimentary falls or falls. So, we know that these extrabasinal sediments, they are formed from the weathering of pre-existing rocks that are placed away from the basin, and they are transported to the depositional basin. And this includes for example, conglomerates, the sandstones, and also you see these structures they formed during deposition of enclosing sediments. They are given in this table where you can see this is the classification of the limestones for the interbasinal or the autochthonous sediments. Here you can see the differences where the autochthonous limestones they are associated with shales, and where the allochthonous sediments, where the allochthonous limestones they are associated with orthoquartzites. Like here you can see the autochthonous limestone, here they are having biogea fossils, and for allochthonous limestone you can see rolled fossils. Likewise, here you can see unsorted as to size, and in allochthonous you can see they are sorted to size. So, here the difference is given in this classification of limestone. So, autochthonous or the intrabasinal sediments, they are made up of particles that they originate within the basin and they are deposited there itself. So, more than half of the minerals found in the intrabasinal rocks, they are the carbonate, that includes the calcite, dolomite, magnesite, and there are also others. So, then Petrology he suggested a classification that you can see in this table that I have already discussed, where he have given the differences between the autochthonous limestone and the allochthonous limestone. So, now let us discuss about the classification of carbonate rocks. This is proposed by Daham, where this classification is based on the depositional textures. So, Daham's classification of carbonate rocks, they are defined on the basis of following three criteria. They are the supporting fabric of the original sediment, then the presence or absence of the mud, that is the fraction which is less than 20 micrometer in size, and the third is the evidence that the sediments were organically bound at the time of deposition. So, this is the Daham's classification, and as per Daham's classification, mudstones are those that the mud supported carbonate rocks that contains less than 10% of the grains. And for the whackstone, this mud supported carbonate lithology with greater than 10% grains. And the peckstones, this is the grain supported fabric with 1% or more fraction of mud. Then grainstone, these are grain supported carbonate rock with less than 1% mud. And for bound stone, here where there is indication that the carbonate sediments were bound by organisms at the time of deposition. And for crystalline carbonate, that for limestone and dolomite, where the recrystallization has resulted in the original depositional fabric of the carbonate rock. So, learners, let me summarize what I have discussed in this session. You see, sedimentary rocks can be classified based on mineralogical composition, chemical composition, texture, size and shapes of grain, mode of origin, depositional basin. And on the basis of origin of sedimentary rocks, they are classified as allogenic minerals and orthogenic minerals. And on the basis of chemical composition, they are subdivided into siliceous, carbonate, ferruginous and phosphatic deposits. On the basis of textures, sedimentary rocks are classified into clastic and non-clastic. Then terragenous rocks are classified on the basis of size and shape of grains into rudiceous, arenaceous and argillaceous. And the sedimentary rocks, based on their mode and mechanism of accumulation and consolidation, have been classified into 4 broad groups: residual sediments, mechanical sediments, chemical sedimentary rocks and organic sedimentary rocks. And the sedimentary rocks can be classified on the basis of depositional basin as extrabasinal or allochthonous and intrabasinal or autochthonous. Thank you, learners.